Hello, welcome to part 8 of Neurons 2. This is the last one for this for this section. This is a short one. It's about the different kinds of neurotransmitters. I've only spoken of them generically. We're not going to go into the lists and lists of neurotransmitters and what they do. You can look that up, but I'm going to just give you some ideas and some facts about different neurotransmitters. There are many kinds. The one that we talk about a lot is acetylcholine because it's excitatory in the central nervous system and in the neuromuscular junction. So we're talking about one cell exciting the other one. We often are referring to acetylcholine. Another example of a different neurotransmitter is serotonin. And this you've probably heard of. It's important in the regulation of mood, of behavior, of appetite, cerebral circulation, and so it's sort of a feel-good neurotransmitter. And you've heard of Prozac. So Prozac, what it does is that it blocks the serotonin uptake. So if you could have serotonin in the neuromuscular junction last a longer time and not be recycled, or if you don't reuptake it, it's going to stay in that neuromuscular junction. So that's what Prozac does. It blocks the reabsorption of it, and that feel-good sensation will last for longer with your own serotonin that you're releasing yourself. What about dopamine? So dopamine is very important in the control of skeletal muscle movement. You know that patients with Parkinson's disease that are low on dopamine have skeletal muscle movement problems. They can't initiate movement. They believe they're stuck sometimes. They can't initiate. They'll want to move and they're not able to. Or sometimes they have excessive movement, which is like in the wrist when the hand shakes. That handshake is also, controlling that movement of that skeletal muscle. So that's dopamine is going to do that. What about norepinephrine or noradrenaline, another word for the same molecule? This is going to control smooth and cardiac muscles. So we think of adrenaline as fight or flight response and initiating stronger contractions of the heart, faster contractions of the heart. Some other interesting neurotransmitters or toxins is the botulism bacterial toxin. Think of what this does. It's crazy. It prevents the release of acetylcholine. Can you imagine if you had a molecule that was able to prevent the release of a neurotransmitter? So here's a toxin that just sort of messes with your nervous system intensely. What it does is it inhibits the exocytosis of the vesicles of acetylcholine, and it stays there in the presynaptic cell. Well, what it does is it digests the proteins in those vesicles. Is that crazy that one particular toxin can be so specific in its action? And by doing that, it ends up, if you don't have that acetylcholine functioning, then it's going to cause paralysis. So flaccid paralysis is just the inability to initiate that movement or that contact, given the contact between these two cells. So in the neuromuscular junction, the muscle is not going to respond. Another interesting chemical is Botox. It's a neurotoxin also that's injected. And what it does, it also prevents the release of acetylcholine. If it prevents the release of acetylcholine in that neuromuscular junction, the muscle doesn't respond. And if it doesn't respond, it relaxes. And if it relaxes, you stop with those wrinkles because you've been contracting muscles that cause that wrinkling. So that's what Botox does. It lasts not eternally. It lasts around 3 to 4 months. And then it's broken down, and then that muscle contracts again. So this is telling you here it causes the paralysis of those tensed facial muscles. Relaxing the muscles removes the wrinkles. Other medical uses of Botox are severe underarm sweating. This can be a problem. It can be really embarrassing for individuals who have this problem. and it can stop that if you prevent those cells from actually releasing water. Cervical dystonia, also a neurological disorder that causes really bad neck and shoulder muscle contractions. That's what dystonia is. It's used for that. It can stop that that connection that's causing you to have those contractions, those unwanted contractions. Uncontrollable blinking can be solved. Misaligned eyes, strabismus, and some individuals have had luck with chronic migraines, overactive bladder. So these are all situations where some cell is overactive and you can actually slow it down. What about local anesthetics? What did they do? So they block the conduction of an action potential. If you block the conduction of an action potential, you don't feel pain. It's very interesting. They function in very different ways. I always tell the story that one year I invited an anesthesiologist to come to class and talk to us about these different mechanisms. And I was surprised to hear that many mechanisms are actually not well understood. We use them because we know the dosage and we know what works, but not necessarily know the mechanism, which is kind of mind-boggling. But there you are. So lidocaine in the mouth, it binds to sites on the sodium channel. So it sort of blocks that sodium channel from opening. If you don't have a sodium channel that can open, then you don't have an action potential and you're not going to feel pain. It's brilliant. What about gamma-aminobutyric acid, which is GABA? It's used at a neuromuscular junction to also inhibit muscle contraction. This is a classic example of an inhibitory neurotransmitter. It prevents spastic paralysis. Spastic paralysis would be two opposing muscles, antagonistic muscles that contract at the same time. So if your biceps and your triceps were to contract at the same time, what would happen? You'd desperately stretch out your arm and it would be kind of spastically moving as both of these muscles try and both work in opposition to each other. So we don't want that. So we have this neurotransmitter that when you're flexing your arm and the flexors are functioning, then the extensors are releasing GABA and they're not allowing the contraction so that you wouldn't have this spastic paralysis. Another interesting toxin is tetanus. What it does is it prevents the release of GABA. So what happens is if you want to prevent the release of a neurotransmitter that is a dampener, right, of an action, it's also going to block exocytosis of the GABA. So when something should be hyperpolarized and you should drop from negative 70 millivolts to minus 80 or 90, but you prevent the exocytosis of that GABA, that's never going to happen. And so the tetanus toxin causes things like lockjaw, where that muscle just stays in that contracted state. Cocaine is interesting. What it does is it binds to reuptake transporters of some neurotransmitters, like dopamine. So if you're releasing dopamine, and there's, again, dopamine also has the feel-good sort of effect on individuals, and you could eliminate the reuptake of that dopamine. and leave that dopamine longer in that synaptic cleft, and that's going to give that feel-good sensation to that individual. It causes overstimulation of pathways because you should end, this pathway should be stimulatory and then it should cut. But by preventing that, it's going to cause overstimulation of these pathways, both dopamine and serotonin. They stay in the synaptic cleft longer. And there's some videos I'll post for you on the effects of caffeine. And this is where we end these videos for this one section of Module 6. Thank you all.